my blabber. It is my great privilege to introduce Mars. Mars is the co-founder and CTO of Metaphor Data. Was one of the great minds behind DataHub and has previously worked at LinkedIn. So please join me in welcoming Mars. Take it away, Mars.
Hey, thanks. Great to be here, and thanks for inviting me over. Let me kick off my talk by sharing my screen. Give me a second here. Alrighty. Okay, can you all see my screen? Cool. Like I mentioned at the top there, the title might be a little bit clickbaity. So if you got baited into coming here, that means I was successful. But I'm here today. I'm going to talk about how you can tame the data beast using DataHub. I'll explain what the data beast is. Hopefully, everybody has an idea of what that is already. And if you have not heard about DataHub, I hope you come away knowing what it is and give it a try later on. It's open source, so you can go and play with it if you want. So a short blurb about myself. I'm the co-creator of DataHub, as Andrew mentioned at the top. And I'm 1 week CTO of Metaphor Data. Prior to that, I was at LinkedIn for about 4 years as the tech lead for the metadata team. It was a fairly sizable team at its peak, about 16, 17 engineers. And prior to that, I was at Google for about 3.5 years, working on Google Cloud and a bit of dabble in Android as well. And I came to the US to do my PhD in computer science. And here's my Twitter handle, so feel free to follow me. I don't use Twitter a whole lot, but if you use, do follow me. Hopefully, I'll post something interesting there. And here's the bit. I'm actually a Kiwi. For those who didn't know, you probably can't tell from my accent. My accent is pretty weak now. I came to the US a long time ago. But yeah, I grew up in New Zealand. I did my college there, as in like high school college, not. And then the uni over there as well. I actually went to Auckland Uni for my undergrad and for my master's degrees in EE. So, oops, actually there was a mistake there. It should be 2011. I don't know how I typed in 2017, but almost a decade ago, Mark Andreessen, famously for Netscape, obviously, said this word, right? I mean, say this critical sentence: software is eating the world. 10 years later, nearly, I think everybody is now thinking that data is actually a thing that's eating the world, not software. And then by eating, it's like literally, physically eating it, as well as figuratively eating the world. Here are some of the macro trends that hopefully you all observe in your day-to-day work. There is definitely a trend of democratization of data. Which means things just get a lot more organic, right? You've probably heard of those from this software would no doubt have heard of data mesh, but there's decentralized data governance, self-service, remote work, right? All of these factors are sort of driving more and more democratization of data. And you start hearing more and more of these different roles that are data related: data scientists, analysts, engineer, right? AI, ML engineers, business analysts, users, and so on. So you start having all these different personas come into the data world, whereas it used to be very simple, maybe just the engineers around and maybe a data scientist trying to use the data. Now you have an ecosystem that's trying to serve multiple personas. And of course, it didn't help that we have an explosion of various different data systems and tools. Things just get more and more complex. No doubt you have seen some of these or use some of these technology, but the list just keep going on. I often give the joke that every second week you're gonna hear a new startup that's building this fantastic AI framework or DevOps pipeline and whatnot, and your head just starts spinning and you don't know what to use and what to not use. And of course, cloud didn't help either. Cloud didn't actually make things cheaper, but that just means you end up storing more, creating more, and then things just get bigger. And the sort of the other, on the other hand, regulatory pressure start mounting. Famously, all these four letter words will probably ring a lot of bells. GDPR, CCPA, et cetera, right? So on the other hand, as a company, you try to get more and more control on ever-growing quote unquote beast. So what do those trends lead to, right? So first of all, you probably heard of this all the time. Finding data become harder and harder, right? Famously, if you have a data lake, no, you don't. You really have a data swamp, right? Because you dump everything there and then don't take care of it. It just becomes a swamp. You have siloed team, right? Guess what? They produce siloed data. And then you have specialized system. Well, guess what? You have specialized data. So things just getting like more and more heterogeneous, and finding stuff become much harder. And managing data also become hard. And this is probably a lot more relevant to data engineer, right? I mean, trying to apply governance, compliance, and anything that's kind of policy driven becomes much harder in this environment. And finally, this is the big one. You hear people say all the time as well, okay, assuming you finally find the data you want, guess what? Trusting it is often an issue. But the way I look at it is, it's not about trust. It's not like I trust you as a human sort of trust, right? It's about information, and specifically contextual information, right? If you find the data and you don't know its lineage, you don't know its availability, you don't know its quality, you don't know its distribution, you don't know who owns it, where's the documentation, right? Then no doubt you will not trust it. How can you trust it? But on the contrary, if you have all of that information at your fingertip, then you can easily make an educated decision on whether you want to trust this data or not. So trust is really related to, sort of information availability rather than trust. All right, so what's the solution? Well, I already put it out there. You already see the answer there. This is kind of a play on the famous adage in real estate, right? Location, it's all about location. When it comes to data management or taming the data beast, it's all about metadata. But what is metadata? I mean, different people have different interpretations. It's kind of a very generic term. So I'll give you a very simple example here, right? This is as easy as it gets as a data set, right? It's a spreadsheet, essentially, right? You have 4 columns, all the columns have title, right? Some sort of title, and they all have value. But if you were given a spreadsheet without any context whatsoever, I doubt anyone can interpret this in any way, right? So very quickly, you start asking the proverbial, 6W question, right? Okay, well, when is this last updated? What does each column mean? Who created this? Why is it a null value there? Where did the data come from? How was the value column computed? You're gonna start asking all these questions in order to understand this data. And the answer to those questions is metadata, okay? So data about data, that is the very definition of metadata, which is kind of treated as sort of context around the data. So here I'll talk a little bit about LinkedIn's metadata journey. This is obviously close and dear to my heart because I was there for about 4 years and seeing the entire journey. But we do believe this is applicable to definitely companies beyond LinkedIn. LinkedIn is the pride itself as kind of ahead of the curve in terms of data maturity and whatnot. So we get to see some of these things ahead of other people. So our hope is that we can instill these to other knows that what sort of what to look ahead of them. So it all started in about 2016. Okay, so like 4 years ago. This is a time when LinkedIn just started going down this, okay, we're gonna be like very data driven. Everything's gonna be we're a data company, not a consumer web company, right? And then we have like we're gonna really scale out our data science team. And this is a time when data engineer, especially, right, and then a lot of you can probably relate, start realizing that they themselves kind of become the bottleneck of data scientists, because the data scientists will keep coming to data engineers and say, wow, do you have this data? Where's this data? Where did you ETL this data to the warehouse there, et cetera, et cetera. And they realize that the only way to make this scalable is by giving the power to the data scientists and say, well, here's the tool, you just go and use it and you'll find the stuff that you need, right? Don't come and ask, a human being every time. And this is where this project called Warehouse, right? It's a pun to play on the data warehouse, but it was like, where is the data? How did it get there? That was kind of the name, original name. Warehouse was created inside of LinkedIn, right? And then we often joke about this, saying that, well, if you have a new grad joining the company and you give him like the project, say, well, you have 2 months to create a data catalog for the company, and that will be Warehouse. So it was a very simple system, very naive. It basically has a bunch of these so-called crawlers, right? So these crawlers will just wake up periodically and then just go and ping every systems and grab metadata from there, put it in the search index, slap an ad on top and call it a day. Right? That's pretty much it. And of course, that's kind of largely inspired by Google as a search engine, so to speak. So a pool-based system, right? You have these crawler, a monolithic app that basically is the front end and the back end, everything is just like one app. And kind of the bare minimal data modeling if it applies, just like literally stuffing things into SQL tables. That's it. Nonetheless, it was open sourced in 2016. And guess what? It was the very first open source project in this category. So since then, almost pretty much every single big tech, nameable tech company have attempted something similar. Some of them open source and some of them didn't. But this is the granddaddy of them all. So the second phase of this journey sort of coincide with me joining LinkedIn. And this is the phase when we realized that, hey, that warehousing that we did, initially it was really just used for searching data, finding a search and discovery use case. But hey, actually, it's very useful for something else, because now you have the metadata. You kind of have the visibility into the entire data ecosystem. So you can actually do a lot more interesting things. And this is actually also the time when GDPR became a thing. And this is the time when pretty much every big tech company starts scramble to say, oh, how do we deal with GDPR? Because we never deal with something as comprehensive as this, right? So data privacy all of a sudden became like the top priority for a lot of companies. And my team at the time, 4 engineers, including me, were tasked to kind of solve the data privacy GDPR problem for LinkedIn. So we realized that we had the warehouse, but the warehouse is not very good for this particular purpose. So first thing that we realized is that we have to change this pool-based model, because instead of the team, the metadata team, go in there and then write like 20, 30 different crawler to integrate with 20 different systems that they don't own, in order to pull all these metadata in. It will be a lot more scalable if we turn the table around and go to these individual data systems and then say, hey, look, you guys own these systems, right? You should push the metadata to us instead of the other way around, right? You should, whenever metadata change, push that to us. And then, LinkedIn, obviously famously for creating Kafka, we chose Kafka as that de facto message bus and say, okay, just drop your metadata onto Kafka. We'll go and collect it from the other end, and we'll index it and serve it on the other end. And also because now, whereas in 2016 we have only human using this particular thing that we created, now it's going to be a lot of programmatic access, right? Because when it comes to GDPR, there's a lot of automation. You have system that basically wakes up and then just query all the metadata and then delete things, retain things and move things around and give access and all that. So there's going to be a lot of programmatic API calls for against the metadata service. So we decided to break that monolithic app into a monolithic service, a proper microservice. And the app still sits on top, but as is basically one of the consumer of these metadata. There's still a large chunk of metadata accesses through programmatic. And then we also say, well, that table-based model is really not going to cut it. We need to be a little bit more opinionated, and be a little bit more put some engineering rigor into this. And this is something that we created internally, and we call that V2. We still retain the warehouse moniker, but the service that we had is called TMS. And And I don't know if anybody here could guess what that TMS, those 3 letters stands for, but I'll just spoil it for you. It's actually the metadata service. That's what TMS stands for. And then now comes the 3rd phase, which is 2019. This is time when we say, okay, well, we've solved the GDPR problem for LinkedIn. That's all well and good. But we knew that we sort of did it in kind of a rush, because of the hard deadlines and whatnot. So we sit back and say, hey, what do we do? And what do we like? And what do we not like what we build? Can we build something better out of this? And this is when V3 was born. So one thing we really like about V2 was this Kafka push-based system, right? Because that is how, as I was able to run a small team and then still scale to the whole company scale, right? That is how, and then metadata is all kind of about integrating things. So having this push-based system really works when you try to scale to various things. And we also realized that that monolithic service, TMS, that we had before wasn't a great idea. Most of the company have already moved from monolith into microservices, right? So microservices is really the right way to do any sort of services. So we decided we're gonna do distributed metadata service rather than a single monolithic service. And then finally, we realized that opinionated model that we created during that period also sort of hamstrung us quite a bit in terms of growing. So we say we're gonna make the model generalized. So instead of having a system that's designed just to work with specific kind of metadata models, we're gonna create a system that's generalized and can work with any kind of metadata model you wanna throw at it. And then this is the time we actually also rebrand, if you will, of our old system to DataHub. And then the backend is called GMA. Okay, so once again, you can see that there's a recurring thing here where we create creative abbreviation of things. So GMA actually stands for Generalized Metadata Architecture. And then finally, we after a year, sort of half a year working in production, we decided that this thing works really well. We want to share with the rest of the world, so we open source it, to the rest of the world. Well, and then since then it was like a lot of work, sort of targeting open source and so on. Kubernetes, Dockers, GraphQL, and so on. That's kind of the current place we are right now. Okay, so here's a quick rundown of the architecture for DataHub. So I'll focus your attention to this like pink box here, right? So this is like really like 20,000 feet of looking at the system. So you have basically every system that is capable of producing, storing metadata. We basically call them just a provider, right? These are the systems that are providing metadata. And we ask them to send those metadata, like I mentioned before, to us through Kafka, through a message. And the message is called metadata change event, right? MCE. And then this system here, there's this sort of bluish box at the bottom here. This is GMA. This is the backend, so to speak, the metadata platform. So the metadata platform will ingest those messages come in, and then write it into a serving layer, which speaks RESTly, which is a REST, RESTful interface, protocol, so designed and used widely inside of LinkedIn. And there's also an indexing service that basically keep indexing the metadata as the metadata changes. And then finally, you basically have a bunch of metadata consumer or applications, DataHub just being one of them, to be honest, inside of LinkedIn, that sort of consume or modify these metadata. So this is how it looks like from 20,000 feet. And then, in terms of index, we actually have two different kind of index, right? There's a search index that serve full text for full text searches, and there's also a GraphDB that basically provide graph traversal if need to be. And I'll double click on that a little bit later, why we need a GraphDB. So let me talk a little bit more on the metadata platform. I mean, when we design it, there's a couple of things we have in mind, right? We know that we have to make this scalable, and by scalable we mean basically sort of the consumer web scale stack, right? We don't want to make it so small so it doesn't work with a large amount of metadata. And we support distributed storage, indexing, because this is dependent by other systems, so you really need to look at 4 or 5 nines about uptime, right? And then also scalable in the sense that we want to make sure that the metadata modeling is decentralized. Like I mentioned before, it's a generalized model,
but we want to make sure that each team, whoever need to provide us the metadata, is able to go and define those metadata model themselves. They shouldn't be bottlenecked on a central team to define them for them. And also, this platform has to be enrichable, right? So, it's not a read-only aggregator. It has to be, because there will be human trying to, enhance the data. There will be other systems that are trying to enhance the data and so on and so forth. So you have to basically take both read and write, and allow human to curate some of these metadata. So a read-only sort of a, Google-like system, it wouldn't work because you have to basically have this overlay of metadata on top of it. And of course, you want to be able to support a wide variety of querying because you don't know what kind of application people is going to build on top of you. So you have to be able to support all sorts of different kind of query pattern, like key value, distributed join, full text search, graph traversal, like I mentioned before. And this is why you need actually kind of different kind of indices in order to support these query patterns efficiently. So, as I had alluded previous in the beginning, that the Kafka plays a big part of it. But why do you want to use Kafka or streams for that matter? Right? What are the benefits of it? I'm pretty sure most of you who have got exposure to Kafka kind of know this already. But I'll just quickly run through some of the benefits of using Kafka streams as the core part of the metadata platform for moving data around. Right? Of course, go without saying is near real time. So you get very in order of seconds of delay when the metadata change, the search index will be updated, for example, and so on and so forth. You don't want to wait for a day for everything to get synced up, so to speak. And the nice thing about Kafka is loose coupling, right? Producer didn't need to know anything about consumer and vice versa, right? Unlike an API where if the server is down, then you cannot make calls to it, right? Kafka generally allows you to has this sort of async produce consume patterns where the producer can quickly drop something on the bus and then just walk away from it without worrying about whether it's get consumed eventually or not. And it also has this nice property of queuing things, right? So if you have a very bursty producing patterns, then you don't have to have the API you don't have to have a consumer that sort of match the same scales of it, right? You can basically use Kafka as a buffer to smooth out any spikes in the traffic, and then the consumer can just wake up whenever they feel like, and then go and consume however amount of data that it's capable of consuming. And also Kafka has a very kind of a strict schema enforcement. So it allows you to sort of make sure that producer and consumer speak the same language, right? So that way there's no surprises when the consumer consumes the data on the other end. And Kafka is also very scalable, right? You can really have a large number of reader and a large number of writer sort of almost arbitrarily, and then you can scale because of this partition level parallelism, right? So you can really scale it to a huge amount. I mean, at LinkedIn, I think we process well over trillions of Kafka messages a day or something like that, right? So it's very scalable in that sense. And actually, Kafka, one sort of little known secret about Kafka is it actually can be used as a persistent storage as well, kind of a sort of a weird sequential key value store, if you will. But this is useful for if you want to sort of store the data somewhere and then be able to bootstrap things later, right? If you have a true queue and then a limited size of queue, then you're bound to drop things on the other end. But if you turn on this log compaction functions of Kafka, you can actually treat Kafka like a storage system. And in terms of how we ingest metadata, there is a couple of different patterns. So a lot of time what happens is you may have some services that already have metadata, okay? And then the most obvious way to get metadata out of it is through this crawler pattern. Right? This is basically treating your metadata service as a black box. You say, oh, well, there's no way I can instrument this. I don't even have the source code of this thing. So I'm just gonna write a crawler and just ping the API or grab some sort of exhaust sort of file that's coming out of it and then just grabbing all those metadata. if you have the source code, then you can essentially say, oh, I'm going to instrument my source code such that I'm going to send out metadata events when metadata changes. Right? So that's when it's instrumentable. Or you might say, hey, my metadata service already, have a change stream, metadata change stream coming out of it, right? It's my message format. It's not the same as your message format, but at least I have that change stream coming out already. Then it becomes a sort of event conversion, impedance matching sort of way of getting those metadata. For brand new metadata service, we actually provide a very fancy way of integration. We provide this sort of data access layer, if you will. And basically this thing acts kind of like a man in the middle attack sort of thing, right? We'll basically listen to your data flowing in between your database and coming out of the database, and then automatically emit message on your behalf. And sometimes the metadata even is stored directly as files inside of Git, right? And this patterns also happens a lot inside of LinkedIn. And when this happens, basically you have to build tooling that basically at build time or compile time or publish time to send out all these events. Or even at deploy time, when something gets actually deployed, that's when you send out events. Do a quick time check, make sure we're still okay on time. So this is actually an interesting part. This is talking about the metadata, how the metadata are modeled inside of DataHub. So what happens is we kind of treat it as a graph problem. You have nodes. So nodes are basically entities. Right? These are the things that people kind of talk about, kind of an abstract ideas of things, right? Like data sets, partitions, features, user, groups, experiments, and so on. These things people talk about all the time, right? They might have a physical manifestation that's different from system to system, but people have can kind of generally agree on what a data set is or what a user is, and so on and so forth. So these are the entities, okay? And then between these entities, you have relationships. Okay, this one probably easier to understand, right? Okay, well, data set is owned by a user, right? A group has an admin of this user or has a member of this user, or this data set is derived from that data set, and so on and so forth. So these are edges between those. The thing that we added to the standard graph is this thing called documents, right? These are things that you can kind of attach to these entities. And the name we actually gave to this is called metadata aspects. But think of it as basically these are the full-blown raw metadata that you can basically attach to an entity and say, hey, look, what is the data set, ownership of data set? Here's the entire array of ownerships and all that. What is the membership of a group? Here's the membership. And what's the profile of a user? Here's the profile of the user. Right? And then you can attach, any numbers of different documents to these nodes. And these are your raw metadata. And these are the metadata that your provider produces to you, and you have them attached into this particular metadata graph. So in terms of adoption, inside of LinkedIn, this is a little bit outdated. It's probably coming up to about 2 years. We have integrated this with 40 teams in all projects, and we have more than 30 entities and 200 types of metadata. And the use case is very wide ranging. We started with search and discovery, and of course, data privacy came around. We still control those. We still support those. And there's access control, some life cycle management, data ops, AI, DevOps. All of these things, these use cases are built on top of DataHub inside of LinkedIn over the time. And in terms of open source, once again, this is a little bit outdated, probably 7-8 months, maybe 9 months at this point. We have, 8 companies are using this in their production, 20 companies are building POC or seriously evaluating. And there's a couple of very good success stories that of these companies. You can actually see that it's kind of a very diverse range of companies. Right? Expedia, which is like more of a big, traditional data-driven tech company. Saxo Bank is something that is very, investment bank that is going through digital transformation. And then Spot Hero is like a very small startup, a cloud-native startup. So all of these companies, they all have actually similar problems, and then they all, chose DataHub to use DataHub to solve their problems. And actually, all of them have already shared the experience in our open source repository. If you want to find out more, you can watch the town hall that they presented, or just go through their slide deck find out more. So on the open source roadmap, we actually have a pretty big list of things that we're trying to do. What happens is inside of LinkedIn, we actually have a fairly advanced version of DataHub, but that DataHub itself cannot be easily just open source as is. There's, because there's a lot of LinkedIn specific things in it that is not applicable to open source. So what happens is generally that when we add something new to the system, we will sort of quote unquote trickle down to the open source after these things have been, after these features being battle tested. And then we have to, sometimes it's easy just to open source as is, sometimes actually require some work to sort of generalize this thing so that it's, so we strip all the LinkedIn-ness out of it, so to speak. But, a lot of exciting stuff on the roadmap. The one with the asterisks are sort of like almost finished, not complete, but almost finished, or make good progress already. And we have a proper RFC process for open source community to come and contribute if they want to contribute certain things or propose big changes and whatnot. So I'll run through a couple of screenshots, and these are the ones that actually you see inside of LinkedIn. These are actual these are fake data, of course, but these are actual screenshots that we've taken inside of LinkedIn. The open source one is, your mileage might vary a little bit, but you get a sense of what you can get potentially over time. So here you see pictures of search. Essentially, you get to see how you can search multiple different kind of entities, by just you send a kind of Google-like search, and then you can do facet, and you can you can actually sort of advanced search. You can specify regex and whatnot if you want to. And this is kind of a page for a data set. You can see there's owners there, and you can, there's ACO axis, so relationship, and data group, some of the stuff that are related to data set. And this is a view of a metric. Okay, this is something that we define inside of LinkedIn as a proper entity, as a metric. So definition of metrics and how is it derived and where is it being used and so on. And here's a screenshot of a profile page, right? So you get to see, okay, these are the things that these are all the metrics that I own right now. You can go to look at all the data set that I own, all the charts that I own, dashboard, etc., etc. And you can also maintain your own list, right? You can say, hey, I would like a bunch of entities, so I want to quickly be able to find them. You can, or a bunch of entities that I follow, I can quickly get access to them as well. And this one is giving you a kind of a fine-grained view. Sorry, take it back. So this is actually GraphQL support, right? So you actually get to see a GraphQL API and how all these entities inside of GraphQL relate to each other. So this is a feature that is only inside of LinkedIn right now, but we would definitely be interested in open sourcing it. And here's a lineage graph that's sort of showing. This is kind of a POC inside LinkedIn right now. It's also to show you how, a particular data set, how did each column get derived from the other tables and so on and so forth. So give you a kind of a fine-grained column level lineage view of your data sets. Oops, skip one page. Yeah. So there we go. So if you want to find out more, go to GitHub. You can search DataHub. Hopefully we're the first one up there. If you type it into Google, I think our SEO is reasonably good. You probably find us on the second or third items on the first page. And we have monthly town hall. The schedule is always published on the GitHub repo. So feel free to join if you can. I don't know if the time works out for Australian time. I think it's probably early morning or something like that. I don't know. We also have Slack, and we're pretty active on Slack. So feel free to ping us there. And finally, if you want to make contribution, the PRs are always welcome. And that's it. My email, my LinkedIn, my Twitter. So feel free to add me.
Awesome. Thanks, Mars. That was brilliant. I think we've got one question lined up so far in the chat from Dave Hamilton. Thanks for the presentation, Mars. Can DataHub facilitate the exchange/integration of data between systems or only metadata?
I'm for metadata, but it will facilitate in the sense that I'll give you an example. and this is actually what happened. Yeah. So hypothetically, right? I mean, it is actually happening as well inside LinkedIn. Hypothetically, what you could do is you could say, hey, I have some metadata-driven policy, right? For example, I'll give you a very simple example. If this data set has PII, I will not want to move this thing from one place to another, right? Maybe I'm not allowed to publish this to a production system, or maybe I'm not allowed to move it to the data warehouse, whatever, right? Or it could be something like, and actually we also do this inside LinkedIn as well, when people request access, right? So the access system is say, hey, can I get access to this data set? And then it would basically look at the data set and say, well, the data set say it has this type of data, but not that type of data. So and you are in this kind of group, then okay, I mean you will grant you access to it, for example. Right. And then the third kind of use case inside LinkedIn is obfuscation. Right? So we actually have a cluster of data where these data are kind of obfuscated. So all the PII stripped away, so to speak. Right. So now anyone can go in and then just use it. And then that cluster itself is created through metadata, right? Because whatever system that's creating or doing obfuscation will consult metadata and say, hey, how should I obfuscate this data properly? So yes, it doesn't get involved directly, so to speak, in the data movement per se, or data transformation, but it is used definitely as an important source to decide how to do certain things when it comes to data movement or processes.
Cool. Thank you. Can you see the questions, or would you like me to continue reading them out?
Question, but actually I can also do a quick, like a live demo if that's what people want to see. I mean, I'm okay with either way. People, wise man once told me that I never do a live demo. So I'll see if I can make it work. But if that's what people want to see, I'm happy to do that. Just run through the open source repo, but or can answer questions.
There's a couple of questions lined up. Maybe while we're collecting responses to see, if anyone wants to see a live demo, just put a quick +1 in the chat. While people are doing that, Timothy asks, when you describe profiles, can it capture data profiles, e.g. distribution analysis or of data sets?
The system, like I once mentioned before, itself is very general, right? So you can really throw anything that you want at it. But a lot of time is, where do you get that metadata from in the first place? And that is the part that's kind of a little bit tricky, because sometimes it's different from company to company, right? There are certain things that are everybody sort of standardizing and geared towards, but when it comes to data profile, at least I don't think there's like a clear winner in that field yet that everybody's using. So what happens is that part right now, we are looking at a couple of things, right? Great expectation is something that seems to be gaining a lot of momentum, for example. So we'll look into how we can integrate with them. But the bottom line is, can the system take it? The system can certainly take it, but can you produce it on the other hand? Maybe. So. Nope, I think you're muted.
Let me unmute and I'll try again. Looks like we've got a bunch of folks who would love to see a live demo. Maybe while you're doing the live demo, there was another question about the benefits of DataHub over Apache Atlas. Maybe while you're doing the demo, you could maybe possibly address that.
My demo is pretty short, so that's fine. I can quickly answer that first. Atlas is actually a decent system. Even though it's probably been around for some time, it's pretty decent. I think some of the ideas there was, we'll say we probably even took inspiration from them when we designed DataHub. So Atlas is designed to be a generalized metadata service. And it's built on top of Engineers Graph and all that. So it is pretty nice in that sense, but it is also very heavy. If anyone have used Atlas before would know it's a heavy thing, right? Because you have to, Engineers Graph is built on top of HBase or Cassandra and all that. So in order to just bring that up, you have to, if you don't happen to have all that stack in your system, it's gonna be a little bit painful to bring all that up. And not just that, there's a couple of things that we think is fundamentally flawed with the design, so to speak. One other, and then this gets very technical, but suffice to say that if you really look at the adoption of Apache Atlas compared to DataHub, if you look at those curves, you realize that Apache is really Atlas is really not going anywhere. They've been sort of trailing along, getting some momentum, and this kind of largely attribute to sort of the fact that Atlas was really designed and maintained by Cloudera, right? It used to be probably Hortonwork, and now it's called Cloudera Hortonwork. So it is very Hadoop centric. I mean, it can be used for other systems for sure, but the sort of out-of-box experience is mostly gearing towards Hadoop. And as most of you probably know, Hadoop is really on the way out at this point. So it's kind of unfortunate in that sense. But I think DataHub sort of took advantage of that and said, hey, look, we are on the modern data. We are gearing towards the modern data lake, not the old legacy things. So and that's the adoption basically speaks for it. So. Okay, cool. Let me quickly bring out my demo. All right, let's hope the demo guy smiles at me today. So let's see. Okay, can you all see my screen? Cool, I take that as a yes.
Yes.
Okay, so I've already downloaded a copy. Okay, let me actually. So if you go to DataHub, this is a DataHub GitHub repository, right? We spend some time making sure the documents is all nice and all that. But if you really want to just have a quick spin of it, you clone the repository, and then you can follow the quick start guide, right? And then the quick start basically use Docker to bring up the entire system. There's quite a few things in the container, right? Like I mentioned before, there's a search index, there's graph, there's services, there's ingestion, et cetera. So quite a few things that will need to be bring up for this entire system. But we put them more nicely in the Docker Compose file, so you can just bring it up. And if you want to do Kubernetes, there's also Kubernetes versions of it as well. But what you really end up having to do is to run the script. So if you go to Docker folder here, then you just have to run quick start, and then off you go. So it starts basically pulling down all the images from the Docker repository, sorry, the Docker registry, and then it starts starting things. Right? You can see there's a whole bunch of stuff that's being started. Neo4j is the GraphDB, Zookeeper, Kafka, a bunch of is sort of for Kafka, and the broker is for Kafka. Right, MySQL is for storing the raw metadata and so on and so forth. Right? So you see that the whole thing start bringing up the whole thing. Now, I'll give it a couple of seconds to bring it up. I run it, and because this is run on my laptop, so sometimes it will take a little bit of time. So after this is up and running, you basically have an empty copy of DataHub. So if I show you after this, you see that there's nothing. The DataHub has nothing in it other than kind of a default DataHub user that was created. The next exercise I'll do is I'm basically going to ingest a bunch of data to Kafka, right? I'm going to kind of fake them by, basically writing them in a big JSON file, right? And then you can see these are the things that we're trying to emit, pretending that we are a crawler or some system that produce all these metadata. So we'll basically take this and then send it to Kafka, and then on the other end, that DataHub will just pick that up through its ingestion pipeline, and then index everything for you so they can search them afterward. So just wait for a little bit for that to start up. Let me see, any other questions in the chat that you can answer?
No more questions at this stage. If anyone's got any more questions, fire them in the chat.
Okay, I think it is ready. So yeah, the log is quiet now. So everything is fully started. So now let me go to, oh, can you see my browser? Sorry. I guess you probably can't. Let me reshare this as a whole screen so you can see that. Okay. You can see my browser now, yeah?
Yes.
Cool. So I'm gonna bring up, Okay, I'm gonna bring up the copy. Ooh, okay. The demo guy's not happy with me today. Let me see. Looks like everything started correctly. Or maybe it's still starting. Oh, sorry. Yeah, sorry, maybe it's still starting. It's a bit premature. I think Zoom also consumes quite a bit of my CPU, so yeah, you can see it's still starting. Okay. Anyone has any other question? Meanwhile? Okay. No. Sorry, still going. Yeah, I think it generally start up pretty fast. But I think maybe because of me running Zoom at the same time with the fancy background that's using up all the CPU. Okay, I think this time's for good. We probably actually started. Let's see. Nope, still going. Oh, well, I guess that didn't really work. Okay, too bad. So, so I guess we will probably have to live without a live demo today. Sorry.
Beaten by the live demo gremlins again. But this seems like a good time for you to go and grab the repo and pull it down and try and run it up on your own machine.
So, any other questions?
There was one other question coming in. Is from Brian. Is DataHub just like Lyft Amundsen?
It is just like Lyft Amundsen, but better. Way better. And of course, I'm biased. No, jokes aside, I think there is a big fundamental difference between the two projects in the sense that, you know, I'm saying it as objective as I could. Like I say, I'm biased, of course. I'm heavily involved in the project and whatnot. But to a great extent, if you remember the LinkedIn metadata journey I showed before, to a great extent, Amundsen is kind of our V1, maybe V1.5 at best, right? It is a pretty good catalog, but it is just a catalog. And DataHub has been through that ourselves already, right? We realize that, yes, if your aim is just to stop at data catalog, then you know that's good enough. But as soon as you actually want to start expanding in all different directions, first of all, you want to become a proper metadata service. You know, you want to start onboarding all sorts of different things onto your system. Very quickly, that system will fall apart. Because we know that because we've been through that ourselves. And then that's why we rewrote it 3 times to get it right. Right. So like I said, I mean, it is a great project by all means, but we kind of foresee that things will probably start, they'll start hitting the bottlenecks. In fact, we start seeing the discussion already on that front end when people start asking, oh, can we do push-based metadata ingestion? And you know, can we like start editing metadata and all that? Right? All those questions is basically the stuff that we faced, you know, 2-3 years ago. So we're actually not surprised at all by this. But you know, it is a very interesting project. It gets a lot of attention as well. So I'll encourage you to look at both if you're interested in this field, and then do your own comparison and drive your own conclusion.
Great. Well, I think that might be the end of our questions. Please give me join me in giving a wave, a silent round of applause for Mars and that amazing presentation. Thank you so much, Mars. We will. Any links to any of that stuff, I'm sure Mars will post in the Meetup group page, so you can access the repo, play with the stuff, et cetera, et cetera. So thanks again, Mars. What we'll do now is roll into the end of the Meetup. We'll do the quick final bits. We'll do the marketplace section. So this is where you've got your chance to get up and spruik your wares if you're looking to hire someone in particular, or find other people to work on your open source thing, or anything like that. This is the time to do it. Does anybody, if you do have something, just throw your name in the chat so we can, so we don't have a whole pile of people unmuting at once. Do we have, and remember these guidelines. Does anyone have anything to plug? Cool. Burger, please go ahead.
Yes, thanks, Andy. So I work for a company called Do It International, and we're a Amazon and Google partner. On the 10th of December, we're hosting a free immersion day on EC2 Spot instances, so in collaboration with AWS. So Thursday, the 10th of December from 9 a.m. to 1 p.m. I've posted the link in the chat. It's completely free, suitable. It's online, so suitable for anyone in the sort of Australia East time zone or even New Zealand time zone. Yeah, I'd love to see you there. Or if you know anyone who you think would benefit from this topic and learning more about how to save money with it, please come.
Cool. That sounds like it would be of huge interest to data engineers. Get on that. Cool. All right. Mai Shinkai, step up to the plate, please.
Sure. Hello. Hi, everyone. My name is Mai. I'm from PageUp. We do have a senior data engineering role coming up within our business. I don't have the job post yet, but once we do, we'll share more about the job link in the Meetup page. PageUp is a talent management SaaS company, really doing some amazing things. So hopefully someone will be interested in joining us. Thank you.
Great. Thanks, Mai. Anyone else? Any other final plugs before we wrap up? Gone. All right. Thank you, Burger and Mai. Please don't forget to post the details of those things on the Meetup event page so folks can find it when they're available. All right. So to finish up, thanks to ThoughtWorks. ThoughtWorks, have been hosting this meetup, both in person and online since the beginning, and continue to provide support to the community and have continued to ask very little in return. So we offer our thanks to ThoughtWorks. I think that is it. This was the final meetup of the year. The end of December tends not to be such a good time to host a meetup, so we usually skip December. Our next event is going to be at the end of January, Thursday, 28th of January. We're going to be back to evenings, probably virtually. Don't know. We may be able to do something in person. Who knows what next year is going to hold, but whatever it is going to be exciting. There's going to be plenty of data engineering stuff to talk about, onwards and upwards for the data engineering Melbourne community. If you need to get in contact with us, if you've got a great idea for a talk, we love lightning talks. We love, full half-hour talks, anything in between about any topic, that might be vaguely interesting to data engineers. Please get in touch with Harmeet, Tim, or I. Well, thanks thanks for coming, everyone. Thank you for sharing your lunchtime with us. Thanks again to Mars. Fascinating talk, about a fascinating and very valuable product. Thanks again to you all. Hope to see you again, either in person or virtually. Thanks, folks. Enjoy your afternoons.